Hello, this is Mr. Griffith, and we're going to be talking today about sets and whole numbers and properties that whole numbers possess. And we're going to be seeing how we can define properties and operations of whole numbers by looking at sets. Now, if you remember, we had discussed the idea that a whole number is a property that a set possesses that answers the question, how many? So we're going to take a look at some ideas of sets first, and then go on to work with whole number operations. So the first thing we want to do is we want to remember some of our definitions. Of course, the U is the universal set, okay? And the universal set is essentially the set of everything. And then we can sort of look at that set as sort of a, here's this is everything. That's all that there is. And I can have a set in here and call this set A, okay? And this set has possibly something in it, okay? And here is a set B, and it also can have something in it. Now, if I want to describe what's happening with these sets and these relationships, I have a few operations about sets and their contents that can go into this. So I'll tell you what, let's let set A be A, B, we'll call this C, D, E, F, and G, H out here. So you can see, by the way, that set A is the set containing A, B, C, and D, and set B is the set containing C, D, E, and F. Now, so if I want to talk about the things that the sets have in common, okay, here's what the sets have in common right here, all right. I can talk about a set construct called an intersection, okay. An intersection, okay, defines the region or set, okay, of elements containing all elements held in common. So here's the symbolism. Here's the symbolism. A intersect B. Okay. Now, what is A intersect B? Well, it's all the elements that are in common. Visually, you can see those, the C and D are in set A, and C and D are in set B. So here's this from just a set perspective. So I can say that A intersect B is the set C and D. So we take a look at these, this, and intersection is one of these things. So these two sets have an intersection. Well, let's suppose that here's A, and here's B, and let's A, B, C, D, E, F, and G, okay. And so A, B, C, and D, E, and G. And again, if we wanted to talk about the intersection, you can say they do not intersect. That is, they have nothing in common. These sets here, if they have no elements in common, okay, means that the set of elements they have in common is empty. That is, the intersection of A and B is empty. Now, these sets here, A and B here, are called disjoint. And disjoint means they have no elements in common. Now, so, you know, I can have an intersection, or I can not have an intersection. Or if, let's put it this way, if I have no intersection, we can say that the intersection, the set of elements held in common, is empty. So what else can we do with these sets? Well, we can talk about putting sets together, combining sets. We do that all the time. So here, let's do this. So here's A, B, C, D, and E. This is set B right here. So we're going to take a look at this. And we're now going to talk about putting the sets together. And so we're going to deal with something called a union. All right, so this is union. And we say that the union of two sets is the set of all elements from let's say found in either set. Okay, so that is A union B is going to contain all the elements in A, B, and C. It is going to contain all the elements in set B, so C and D. So there they are. Now you can understand that set A has 3 elements in it, and set B here has 2 elements. But the union of these 2 sets only has 4 elements. So you can see that putting 2 sets together that are not disjoint is going to create a new set, but we don't ever list these elements twice. Okay, so the number of elements here is not going to be the number of elements here plus the number of elements here. This is very, very important because we are going to come to a place where we see a union as a way to define addition, but only in a particular situation, that is where we have disjoint sets. Okay, so here the union of 2 sets, set of all elements found in either set. So what's the idea of a union? A union is where you would do some combining. So you're going to combine the sets. Okay. Well now, what then? Well, you know, with the universal set being all that there is, you know, we can play with some ideas here. So let's think about these sets here, and let's think about here we see that A intersect B here. The intersection is just simply the set containing C. because C is the only element they have in common. A union B, as we said, is A, B, C, and D. There's that. I could deal with something called a set difference, where I could talk about A minus B. And here, this idea of a set difference, what I would do is I would take everything that was in A, and that's what I would start off with, just like you start off with something in subtraction. And I would take away everything that was in set B, and I would look at what remains, and so all I would have left there is A and B. Suppose I wanted to talk about A union A. Okay. Well, here this is putting A together with A, joining A together with A. Well, if you join it together with itself, you just have A. Okay. And then I could talk about A intersect A. And here I'm asking, what does A have in common with A? And of course, that would just simply be A. Now, if I were to ask what A had in common with the universal set, okay, you can see the universal set is A, B, C, D, and E. What does A have in common with the universal set? Well, just A, B, and C, that is. It has that in common with the universal set. Here, if I were to ask what would happen if I joined A together with everything in the universal set, well, if I put A together with everything in the universal set, remember A is part of the universal set, okay? Well, then I would just simply have the universal set. What about some other little things? Well, suppose here I took a union, I'm putting things together with the empty set. Now, what does that do? Well, this essentially says I am adding into set A everything that's in here, right? Okay, well, obviously, if you add nothing to it, you have what you started with, right? Okay, and here I'm asking, well, what does A have in common with the empty set? Well, remember now, here A is A, B, and C, and here the empty set is there, and my result is all those elements that are in common. I don't have any elements in common, so obviously, since I don't have any elements in common, A intersect the empty set would just simply be the empty set. You can see here that we can play with some of these structures here in a union and intersection. Well, what's really interesting about all of this is that that sets provide the basis for us to even be able to talk about things like addition and subtraction.